Theory, law, discovery, inventions. In order for scientists to go through these processes, one must start with scientific methods. So, what is a scientific method? Scientific method is a method of research with defined steps that include experiments and careful observations. In this image, show a cycle of that defined steps. Starts with the question observation, hypotheses, experiment, collecting data, analysis, and conclusion. This cycle repeats over and over again with a scientist or many scientists to come up with, say, a proof of something existence or a proof of something that should not be there, or proof of discovery of a medicine, what have you. They all go through this scientific method in order to come up with a final conclusion. Here's a very simple example of the scientific method. So say you start with a question and perhaps even a observation and prediction. So you question, hey, why doesn't my toaster work? And you try toasting something in the morning, but it doesn't work. And then you question, well, must be something wrong with the kitchen outlet. And that's your question. And you have this prediction. Then you come up with this hypothesis that, well, if something is wrong with the kitchen outlet, then my toaster will toast probably in the living room outlet. So what this person or scientist is saying, nothing's wrong with the toaster. The issue is the outlet. And is this testable? Can you test it out? Yeah, you simply need to just take the toaster and plug it into the living room and see if it works. So that we can come up with various experiments, come up with materials and whatnot. So one of the material will be like the toaster. Then you have the bread, and you must have the same type of bread, right? These will be your control. The environment has to be the same, not a rainy day. It has to be a day that is 70 degrees, and you're going to test it out in the living room outlet. So that would be your variable. You test it on the living room outlet. Maybe you do it in the bathroom outlet. You do a bunch of outlets to really test that nothing's wrong with the toaster, but it's the outlet in the kitchen that was the issue. Then you start collecting data. Okay, did it work in the living room? No, it didn't. Okay, you go and try the same bread, same weather, maybe even the same day. You go all around the house, and the answer is no, it doesn't work. So you start going to the neighbors. You try it into the neighbor's kitchen and everywhere, and it doesn't work. You start analyzing those results. Okay, so if this happened, this happened. If I did this, this happened. Maybe potentially, maybe I need to do something else. And you start thinking. So you start analyzing the results that you got from the collection of the data. Then you come up with a final conclusion. So you can conclude, all right, I admit it's not the outlets the issue. And then you might think, well, it must be the bread, right? Not the toaster, but it's the bread. And you swear that if you switch from white to wheat, then it will work. And that's your conclusion. And then so you start to go and do another experiment, come up with another hypothesis, and you go through this collecting data, analyzing results, and conclusion. Or say the conclusion could be that your hypothesis was correct, and it worked in the living room outlet, and it worked in all the other parts of the home. And so it wasn't the outlet wasn't the issue. I'm sorry, it wasn't the toaster issue. It was the outlet that was the issue in the kitchen. So you might have a conclusion, but you still have to go through another experiment. Is it really the kitchen outlet? And then you start testing your cell phone chargers, your laptop chargers. And then the series of these experiments come up with some discovery, inventions, and even theory. And so this scientific method is very important in science in order to come up with these important processes.